Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? Sorry, I'm still fighting being sick. No. Hopefully today's the last day. I want this to be the last day being sick. I don't like this being sick thing. Although I think I had the worst of it last night. Hopefully. We can hope. Hopefully. Yeah. Let's see. Today's Monday, start of the week. In the United States, this is a holiday, technically. It's MLK Day. Martin Luther King. Cool guy. Did a lot for civil rights back in like the 60s and 70s. So a lot of you guys don't have school, which is great. Hope you guys are enjoying. It's a 3-day weekend. Let's see. Other news? What's up, Star Prod? Star Prod's first. What's up, Star Prod? Yeah, I canceled all my in-person tutoring today. I was like, no. Like, I don't want to get kids sick. Like, I'm 100% sick. And, like, I told the students, my in-person students, I'm just like, if I teach you, like, it's not a good idea. So. No. You have no audio. Oh, I think the audio should be working. But the nice thing about online is you cannot transmit biological diseases across the airwaves, the internet, the series of tubes we call the internet. So this is still totally safe. Although I don't know how much of... Oh, you can hear me. Good. We'll see how much endurance I have to go through this. We will have a stream tomorrow. Tomorrow is going to be the last stream of the week. Because then Wednesday, I got to fly out to Seattle to go see my family. We didn't meet up for Christmas because half of them are in, like, healthcare. And it's, like, it's hard to get, like, the sick don't take a vacation. As evidence here. So we didn't meet up for Christmas, so we're meeting up this week in Seattle. So, no stream on Wednesday. No stream on... Sorry, well, there isn't a stream on Wednesday anyways. Usually, sorry. No stream on Thursday is what I meant to say. And then no gaming stream on Friday. And then no stream on Sunday because I fly back Sunday. But Monday, we'll start it again. So, come on by, enjoy. What's up, Ram? Ram, do you still not have perms to just join the stage? Really? I have to... Let me fix this, dude. What? Whatever. Let me fix this. Because, yeah, alright, one sec. Settings. Permissions. Where are my mods? Stage monitors? I don't know what the fuck. I have like special permissions just for one other person? Wait, one sec. Oh, here we go. Who's a stage monitor? Oh, got it. Okay, here we go. Got it. One sec. There we go. All the gods are now stage moderators. Okay. Great. So now y'all shouldn't have to ever have to request to come on the stage. I think they should have just allowed you on there. Okay, cool. Yeah, enjoy my time. Thank you. I will try Star Prod. So yeah. That's it. No other like crazy news. I started releasing more TikToks, tutorials today. Man, I forgot how much time they take. What's up, JC? That is the one advantage of being sick, is I was just like laying on my couch just editing TikTok videos all day. Because I was like, well, can't do anything else. I can't go outside. I can't go to the gym. Can I see Olaf? You want to see Olaf? Yeah, here. Let's go see Olaf. Here, you want to see Olaf? There's Olaf.
By the way, I'm curious. Did you guys ever go through the...
Go through the what?
Circle? Oh, there we go. Never mind. Speaking of the devil, you brought
Yes.
the circle one. Did you guys figure out the equation?
Naroski did, yeah. Naroski's a G. Yeah, Naroski went through and did it. So it was this, right? It was solving this thing.
Yeah.
I think the key thing here was Naroski didn't expand out some of the terms, and the nice thing was that they eventually just factored out. So when you solved for this, you then got this at the end for just M, which was our answers, right? Either M was 0, right, which means it's flat.
Yeah.
Or M was equal
greater.
to 15 over 8, yeah, or less than 15 over 8.
Sorry, would you mind going up a little bit? I wanted to just see.
Yeah.
The determinant. I wanted to make sure.
I think you had this. This is the same thing you were running.
4 times. Yeah. I think that makes sense.
Yeah. It was cool.
Yeah, I shouldn't have expanded. That's why I got the quartic.
Yeah, and that's what Naroski even like guessed that. He's like, I'm guessing Rampton tried to expand it and then got to like, yeah, the quartic, and it was like, yeah, no, I'm not doing this.
To be honest, it was like after a long day of touring also that I was
oh yeah
pretty...
yeah, you're just zonked. You're like, energy wise, you're like, I'm done.
Yeah.
Fuck this. Yeah, but this is cool. Yeah, we did the last two as well. There was, or actually maybe we didn't do all of them. Wait, oh, we still had. Oh, so maybe we can do these last two, just like because I don't have anyone else on the queue right now. It's a holiday in the U.S. We did.
Why is it a holiday?
It's MLK, Martin Luther King Day.
Oh, okay.
Yeah. Also, I guess it's apparently also Dolly Parton's birthday. Is that real? I saw that on NPR today.
Who's Dolly Parton?
You don't know who Dolly Parton is? Come on, Ram. You know who Dolly Parton is? She's this classic. She's very, very famous, dude. You know who Dolly Parton is?
Oh, okay. Okay, I know.
Yeah, but I think her birthday.
I've seen her with that look, not the.
Yeah, not the younger look. Well, she turned 80 today, I think. Yeah, today's the 19th, right? Yeah, she just turned 80. So I don't know. She was on the news.
Well, now she has to start running for Congress. She's come of age.
Why do I hear these things about like Alberta is gonna secede and become the 51st state? Do you hear this? What's up with Alberta?
Because Alberta, for some reason, they are just like, oh, we want to like, go free because we got a lot of oil and all that stuff. But like, if you look at the votes, all of the people who want to leave, they make up less than 30% of the votes. And
but they're the most
a lot
vocal.
of people. Yeah, but there is like, because at the same time that they are talking about these claims of like, we want to become the 51st state, we want to declare independence, everybody who is like doing something is just, there's a thing in Canada, not in Canada, we don't have it in Ontario, but they have it in Alberta, called the recall option. I don't know if you guys have it in US. but it's
to
when you change-
recall like a governor. Yeah, we do have that. We had it for California. We tried to recall Newsom. Yeah.
Oh, that's great. Apparently, they do not have it in Ontario. I was like, bro, how do you guys get this far
Yeah.
in thing and you don't have that?
You
But
didn't build.
yeah,
didn't
so
build in the safeguards.
apparently some guy was. I was like, they pissed off the wrong person. Some dude went into like and figured out all of the background information on all of the politicians.
Uh huh.
And not like doxing them, but like he found out like everything that should be public information. Like, here are
Right.
the things they voted for. Here are the things they voted against.
Their record.
Here are like, you know, what sort of how much housing they have, if they have like if they are landlords or whatever. And he compiled all of this and put it on the website and put a direct link to having recalls.
Uh huh.
And the number of recalls that went super high for a bunch of politicians in
Oh, I see.
Alberta. So
So Alberta's a mess.
yeah,
That's fun. Okay. I always like to hear. My friend is up in Canada right now, and for some like visit or something, and he's like, "Yo," he keeps getting confused because every time he looks at the price of Bitcoin, it's in like Canadian dollars.
No.
And he gets like
he's
super.
like, oh god.
He's super excited. He's like, "Holy shit, it's at 140,000." I'm like, "Oh yeah, but that's Canadian dollars." But he
Yeah.
keeps saying that like maybe he should move there because I guess the housing prices are cheaper than the U.S. And he's like, Canada has. He seems to think that Canada has their head on the game. But I think hearing from you that like you'd rather be in the U.S. than Canada, right?
To be honest, no.
No, the opinion has
It
changed
depends-
recently.
Okay. Yeah, definitely. Yeah, I think.
Yeah.
I think.
Probably in the last 6 months
You-
it's changed. Yeah, I understand that. Yeah.
I would say so. Yeah, but I would say Canada is also like, it has its ups and downs, but comparatively to like years ago,
Yeah.
it seems like the downs have outscaled significantly more than the ups. That's the only
I see.
thing. It's not that it's like bad place. It's just a lot of the things that used to be great about it are like disappearing at a faster rate than positive.
Like the free healthcare and stuff.
Yes. Like
Yeah.
they're intentionally underfunding the free healthcare, which you're like, okay, well, like if I gotta pay out of pocket and I'm paying all the taxes,
Yeah.
then like
What am I paying for?
what's happening?
Yeah.
Yeah.
Oh, okay. Yeah, we'll see. Okay. I think here let's do like the last 2 questions that Celine posted, and then once we go live on TikTok and YouTube, I'm gonna get flooded with questions anyways. So let's start off the stream. All right, welcome everyone to Actual Education Office Hours. Sup nerds? What's up, Psychode? My name's Dr. Gold. This is a stream that helps you out with math homework, science homework. Let's do some fun limits. Oh, Naroski, yeah, you do have some fun stuff. You do always have fun things to do, Naroski. Okay, Naroski, I'll let you take over then. What do you want to do? Here, join the stage. Join the stage, Naroski. Because I was going to do this, but I don't know. I'd rather do like some fun limits. Let me get us live on the other chats real quick. Starpod, got any optics? No more optics. Starpod said he's done with optics. I'm so happy. Did you join your laptop? Okay, cool. All right.
Sorry, since you said fun limits, I like reminded me. There is a fun math joke, which is every triangle is a love triangle when you love triangle.
Every triangle is a love triangle when you love triangles? Is that what it is?
Yeah.
Oh my god. Every triangle is a love triangle when you love triangles. I do love triangles though. Alright, Narasi's getting on his laptop. I need to fix the stream settings here. There we go. I turned off subscribers only channel. Yeah, should work for everyone. Nice. Boom, boom, boom. Yeah, I think we did all the questions, yes. Or maybe we didn't do all of them. Or there's some weird ones. Pi was asking this? Oh my god. Wait, what? What is that? One second. Okay. Put it out, Star Prod, if you want now. Still waiting for Narosky to... This was one that I think Pi submitted yesterday. Which there's some name for this one. Right? When it's like all these exponents, just exponents to exponents to exponents.
It's just the chain rule.
Is it the chain rule?
Yeah, it's just if you do the derivative of the first one, then you get the second, then you get the third. So it's just a u substitution. So it's just 2 to the u, right? du.
Okay, so you just Alistair, you did write the solution. I just want to say it. No, the Q is uncluttered. There's nothing in the Q.
So then it would be it would be
Oh, Narosky has a limit. Okay,
A?
we'll do that one. You think it's answer choice A? Yes. That's apparently what Alistair and ChatGPT think.
Yeah. Yeah.
So wait, what was this thing here? You said that like let u
So let u
is 2 to the x.
2 to the 2 to the x.
2 to the 2 to the x. Like that?
Yeah. And then what would be like du?
Oh man. du.
Or sorry, there's another 2. There should be 3 2.
Oh, 2 to the 2 to the x.
Yeah. 2 to the
Like this?
Yeah.
Okay. And then du. I gotta remember what the rule is for 2 to the u, 2 to the x, right? It's
so it'd be like
is it like ln of a?
2 to the x. It would just be 2 to the power of whatever.
I thought it was this. Derivative.
And then it's ln. Yeah, ln of the base.
Yeah, that's it. Derivative of a to the x is a to the x ln of a. Oh, I see how that works. Okay.
So it would be like du would be the same exact thing.
A to the x is equal to a to the x ln of a. This is the important thing that you need to know. I need to move this. Come on. Move, girl. There we go. Okay. Right, so if that's true, then du is equal to the same thing, right? 2 to the 2 to the 2 to the x.
Yeah, times
the ln of 2 to the 2 to the 2 to the x.
No, it's just ln of the base.
Oh, it's just ln of the base. Oh, it's just ln of 2. Oh, sorry, that's right. Yeah, I got you.
And then times, and then the chain rule, 2 to the 2 to the x.
Oh, times d dx, right? Of 2 to the 2 to the x? Is that what we say?
The x is on the power.
Yeah, there we go, like that.
Because then that's the next step in the chain rule, right?
Correct. But then what's the derivative of this, right?
Yeah.
That's equal to 2 to the 2 to the x, ln of 2, and then it's d dx of
2 to the x.
2 to the x. Oh, this is fascinating. And then this is 2 to the x, ln of 2. Oh, and then that's it, right? I think we did all of them, yeah.
Yeah, and then so the whole integral is just du, but then divided by ln of 2 cubed, because each step of the chain rule gives you an ln.
Oh, okay. Let me see what sorry. So du is equal to 2 to the 2 to the 2 to the x, ln of 2, times 2 to the 2 to the x, times ln of 2, times... Oh, I'm running out of room. times 2 to the x ln of 2, which, okay, I see. Sorry, and then that's dx. So I have ln of 2 cubed, and then all my other terms, right? Yeah. 2 to the 2 to the 2 to the x. 2 to the 2 to the x. 2 to the x dx. Oh, that's super cool. Oh, you're just... Okay, Narowski.
Yeah.
Let me know. Okay. And so, right, the original integral
It's just the integral du.
is just the integral of du. Oh, okay. Just equals u.
But then divided by
But there's a
ln
constant.
cubed.
Because there's a constant. Yeah.
Because what you have is the integral is like all of the 2's with the dx, but you're missing the ln of 2. So that has
I see. Not quite ln of 16 bears. Bryce says, can you do epsilon delta? I can. Submit a screenshot to that, actualofficers.com. I don't know why our chat is not showing up on TikTok, though. Fuck, 1 sec. That's showing up okay. I don't know. I'll figure it out. What's up, Minnie? Everyone else can see you in chat, but TikTok can't see the other chats for some reason. And I'm getting some render delays. Why am I getting render delays? I do notice it. What? Okay. Narowski, you shouldn't have to raise your hand to get on. It should just let you on.
It doesn't, actually. Hello,
I gave you perms. Ugh, okay, what's up?
Yeah, it doesn't matter anyway.
Yeah.
Right.
It does not. But yeah, okay, cool. You're here. 1 sec. Did you come up with a limit you want to go through?
Yeah. I'm actually inclined to give an easier example before we go into that one, because it's there might be some theory that
Okay.
maybe you or other people aren't familiar with.
I like theory. Theory's cool.
So I'm just gonna write it out because it's simpler.
Okay. I can give you whiteboard access if you want to write on the whiteboard.
No, I think I'm just gonna give you a screenshot instead. I think.
Okay. And then I'm gonna go through.
that
I
okay?
got you. That's totally fine.
Yeah.
Okay, this was it, right? Okay, cool. So then this is equal to u over. I just want to like finish this one real quick. 1, 2, 3, and then u we said was this messy thing. Great. So the answer is this. Eek. Move. Good. Over ln of 2 to the 3. Which was that answer choice A? Oh, it was. Oh, but in Mathland, right, I think they call log the natural log, and then you have to say like a log 10 or something for like actual log base 10. Okay, cool. So yeah, this one is answer choice A. That's kind of a fun solution. I like that. Nice. Cool. Copy. There you go. Mathland is where aliens are from. I like Math. Mathland sounds like a cool place. Okay. This is pie. Cool question, pie. Let's see what else we have. I'm just gonna go through whatever wasn't solved before. That one we did. That one we did. We did that one. Delta epsilon proofs. What's 37 plus 30? Don't do it. Don't do it, damage. Don't do it. Don't do it. Mathland sounds like a place where you have your 9th grade birthday party. That would be a fun place, right? Like Chuck E. Cheese's. Well, I guess the whole pie thing would work, right? You could have pie-shaped pie pizza pie, like the symbol. A fun place for nerds, yeah. Mathland.
So this is the limit that.
Oh,
I gave
Narosky,
you
that's
a
what you want me to
helping
do.
hand and the
Got
actual
it.
limit.
Let's do it. Let's
Yeah.
do it. All right, cool. Thanks. All right, cool.
And yeah, this one is like you should be able to do this.
I should be able to do this one, he says. All right, let's see.
Yeah.
The limit as x approaches 0 of 1 plus 5 to the x plus 11 to the x minus 2 over 2 all to the 1 over x. Ooh. Interesting. So when I see stuff like this, my instinct is just to plug in 0 and see like what I think it would do, which I don't think it would be something nice,
Okay,
right?
Yeah.
Let's just do it. So what? That's 1 plus 5 to the 0 plus 11 to the 0 minus 2 all over 2 to the 1 over 0, which is like plus or minus infinity is the issue, I guess, right? It could be like, it could be negative infinity or it could be positive infinity. I see. That's why this limit is not going to exist at first, right? Because
Yeah, so it doesn't matter what kind of infinity you have, it's still infinity.
it's still infinity. But I mean, if it was negative infinity, wouldn't it just be equal to 0 then?
I suppose, yeah.
Right?
I suppose, yeah.
Negative infinity is cool.
Yeah,
Right?
let's see for the purpose of
Yeah.
the example that it's positive infinity.
Yeah. The issue is that there's two radically different things if it's plus or minus infinity. So yeah, we have to.
I think
we have to-
I see a way of doing this.
Okay.
I like this question.
Okay, so this would have been 1 plus 1 minus 2. So this would have been 0. So this would have been 1 to the plus or minus infinity. I'm tempted to say the answer would be 1. Is the answer 1?
So I believe you would be wrong because
I'd be
1 to the power
wrong.
of infinity.
Oh no.
1 to the power of infinity is not actually equal to 1.
If it's exactly 1, it is. The problem is it approaches 1. I guess that's the issue, right?
So
It's like it's
let me give you an example. Let me give you the easiest example. So
okay.
what do you know what the definition of Euler's number is?
Yes.
The
That's
formal
the
definition, the limit definition.
That's the limit as x approaches infinity of 1 plus x, or what is it? 1 plus e? No. Fuck. 1 plus x to the 1 over x or something? Is that it? I think that's it.
No.
I think it's 1 plus 1 over x.
Oh, it's
Yeah,
1 plus 1.
1 plus 1.
Oh, it's 1. Sorry, it's 1 plus. Oh, it's actually as x approaches 0. Oh, I thought it was as x approaches infinity.
Yeah.
Okay, 1 plus x to the 1. Oh, so I was close. It's just it approaches 0, not
Yes,
infinity.
yeah.
What's up, Amir? So this is e to the x, right?
Yeah, sure. Yeah.
Okay. This kind of looks like that, right?
Well, no, it's not e to the x. It's just e.
Oh, it's just e. Sorry. Yeah.
Yeah. E. Yeah. It would
E
be
to the
different
1.
if it was e to the x.
Yeah, it would be really different. No. Okay, yeah, it's just e.
So notice how this is just 1 to the power of infinity if you plug in 0, right?
Correct. Yes, I agree with that. Right.
So this is a big domain in limits, and this is actually called the indeterminate case for 1 to the power of infinity. So whenever you spot infinity over infinity, you know that's
Yeah,
an
this is bad.
indeterminate form. 0 over 0 as well. Infinity
0 over 0 is
over
also-
0 as well.
Mm-hmm. Yeah, 0 over 0. But
Yeah,
0 over
1 to the
infinity,
power of infinity, yeah.
anything over
0
infinity,
over
right?
infinity is not. Yeah, anything over infinity.
Any
is
number
not.
over infinity is always just 0, right? We're cool with that.
Yeah.
Okay.
Yeah.
Okay.
But yeah, so we're gonna treat 1 to the power of infinity as an indeterminate case.
Okay.
Because it is an indeterminate case. And the way you're gonna think about indeterminate cases with 1 to the power of infinity is you're gonna look at the exponent, right? You actually, first off, you want it to be 1 plus something, right? You
I agree.
want the base to be 1 plus something, because
I want
notice
this.
how it matches
I want-
the yeah.
Yes. Right.
it matches the definition of Euler's number.
And then I guess I'm going to make modifications to whatever this is based on this.
Yeah, that's great intuition. Yeah.
Yeah. Okay. Cool. All right. So, let's like redefine something.
How would the initial limit look if it was equal to E? That's my question.
Oh, if this was equal to E.
Yeah. So
Well, this whole thing would just
the
have.
fact, yeah.
Oh, I
Ignore
see.
the
Okay.
fact that it's raised to the power of 1 over x.
Yeah.
Ignore
Okay.
that it's raised to the power of 1 over x. How would you turn that into equal to E?
Equal to E. My gut instinct is to do like a U substitution for this.
Sure, you can say U index x, right? So it's
Yeah.
U of x would be, yeah.
Equal to that, right? And then so I would say
Sure.
that like as x goes to 0, this also goes to 0,
Sure.
right?
Yeah.
And as x goes to 0, U goes to 0. So now I think I'm pretty safe with just saying, oh, I could do the limit as U goes to 0 of 1 plus U, but then this is an issue because it's not 1 over x
Ignore
anymore.
that. Yeah. So let's ignore the fact that it's raised
Okay.
to the power of 1 over x. How
Let's
would you
ignore it.
turn 1 plus U into the definition for E?
I would raise it to the power of U, or the power of 1 over U.
1 over U. Sure.
Yeah, right.
So let's raise that to the power of 1 over U.
Let's do it. I'm down. Okay.
So
Let's raise it to the
if-
power of 1 over U.
Let's do that. 1 over U.
And that is now
This is
sunnily equal to E.
Yeah.
Yes.
This is E.
Gotcha.
But we need to bring back the exponent, right? We messed with the exponent and
We
we
did.
want it to become 1 over x again. So
Yeah.
what happens now? We raise the whole thing, including the fact that we raised it to 1 over u. We raise it again to the power of u, so it cancels.
To get rid of it. Yeah, I see what you're saying. So
Yeah.
I would now take all of this and raise this
Yeah.
to the power of U.
Yeah.
Is that correct?
And actually, yeah, and raise it to the power 1 over x, because we want the 1 over x back. So it's...
Oh, okay.
Yeah.
So you want me to raise it to
Yeah, so-
the U over X maybe?
U,
So we want
u
to-
over x practically, yeah. So
Yeah, let's
u
do that.
over
Let's
x,
say
yeah.
U over X.
So, yeah.
Okay,
Oh,
that's smart.
Yeah.
So now
Yeah.
This-
So now what happens?
this turns into limit as U goes to 0 of just 1 plus U to the 1 over X, right?
Yeah.
Because these cancel.
Which is what we had initially. Yeah.
Good. And then this is E to the U over X. Oh, so it's almost like a chain rule maybe type thing, maybe? Uh-huh.
Yeah, but since
very
we
cool.
brought the x back on the since we brought the x back, since
Yeah.
we brought the x back on the right side, we also we would need to take the limit there of e as well, right? So it would be e to the power of limit as u goes to 0, right? I think that makes sense.
Let me think here. Oh, because we raised it
See?
to the U over X, this also needs to be to the limit as, I think as X approaches 0, no?
X
or no?
approaches 0, and we let's because u is in terms of x, right? So it's a function
Sure.
in terms of x, and we're gonna replace it now. So what was u again?
U was that
It
5
was
to the
5
X
to the x.
plus 11 to the
Yeah,
X minus
so
2 over
let's-
2.
Yeah. So let's just replace it.
Okay, let's replace it. In both cases, I'm guessing, right?
It doesn't matter. You can leave the left hand side now. But sure, yeah. So it makes sense.
Okay. To the 1 over X is equal to the limit as X approaches 0 of E to the whatever this thing is, right? Divided by
Yeah.
X. So E to the X. Okay.
Yeah.
I see.
So now we just care about the right hand side. The left hand side is pointless.
Oh,
right.
Very cool though, right? This is going to end up being 0 over... Oh, it's 0 over 0 though.
No.
Uh-oh.
It's still 0 over 0, right?
Fuck. Yeah, 0 over 0 is not
We're
good.
gonna need to do one last step to evaluate this.
Okay. Is it L'Hopital's rule?
So I believe you can do it with L'Hopital's. I wouldn't do it with L'Hopital's
Okay.
personally. I would pull out a factor 1 over 2 out of the exponent, right? So it would just be e to the power of 1 over 2 times the limit as x goes to 0 of that.
E to the 1 over 2 times the limit
Yeah.
as x approaches 0 of 5 to the x plus 11 to the x minus 2 all over x, right? Okay, cool.
Yeah, you wouldn't need to write the limit twice. You either write it at
Oh,
the
yeah,
exponent
sorry.
or
Yeah.
at the base.
Gotcha. Yeah. Yep, you're correct.
Yeah. So now what would be your instinct to do? You have that exponent, that limit at the exponent. What would be your instinct?
My instinct's always to just plug shit in, but then like that's 0 over 0, which is bad. So, my next instinct, whenever I see 0 over 0, I think L'Hopital's rule, or we could divide by the highest power of x, maybe. No, that's when x is going to infinity. Sorry.
X is going to infinity. In this case, x is going to 0.
Yeah.
A clever way of doing this, notice how you have 5 to the x and 11 to the x, right?
Mm-hmm.
You have two exponential functions divided by x.
Uh-huh. Oh.
I believe
So I
you know
could
that
split
the
it?
exponential function grows faster than x. You can split it into two fractions, each one having -1. So you have 5x minus 1
Well, actually three
over
fractions.
x.
Oh. I see. You're going to distribute the -2 into both of these.
Yeah.
Okay. So
Yeah,
you're going to
this
say...
is what I was trying to...
Oh, okay. So this is the same thing as the limit as x approaches 0 of 5 to the x minus 1 over x plus the limit as x approaches 0 of 11 to the x minus 1 over x. Fascinating. Okay. And I agree that
Do you know
something...
anything about this?
I know that this grows faster than this, sure, but then the 1 over x makes... Well, okay.
So let's slow down. You can apply L'Hopital's if you want now. This is the point where either you know the formula or you don't.
Yeah, I don't know the formula,
So if you don't know, you can apply.
What is the formula though, just for future sense? What's the formula?
So so any exponential function of the form a to the x minus
Yep.
1 all over x when
Yeah.
x goes to 0 is equal to the natural log of the base. So the natural log of a in this case. So anything of the form ax, so a to the x minus 1 over x when x goes to 0 is just the natural log of a.
All right, let's see. I want to do L'Hopital's rule to confirm that for myself.
Yeah, to prove it, yeah.
So, is just equal. You're gonna say the ln of a is what this is.
Yeah, this is what is gonna happen.
Dojo Drummer says because ln of 5 to the x is the derivative. Oh, I see. Oh, okay, yeah. So this is a clever trick. I haven't seen this before. I always love acquiring clever tricks though. So let's do L'Hopital's because yeah, we do have an indeterminate form of 0 over 0.
Yeah.
So L'Hopital's, and we just did this with Rampton earlier. So the derivative of 5 to the x is 5 to the x ln of 5.
Yep.
And then the derivative of x is just 1. Oh, beautiful.
Yeah.
Because then this 5 to the
Goes
and then
to
the
1.
goes to 1. Okay, very cool. This is still the limit as x approaches 0. So this is just equal to ln of 5. Wow. Okay. So then this is the ln of 11.
Yep.
Wow. Okay, cool. This is equal to the ln of 11. So then this is the ln of 55 in total,
Yeah.
right?
But
So-
remember, what was our limit?
As x went to 0.
Yeah, but what was our initial limit?
Oh, it was our initial limit.
Right, so it was e to the power of that limit. See?
Aha. Yes, because then all of this needs to go into, well, it needs to go into here.
So it's just gonna be
E to the 1/2
1
ln of
over
55.
2. Yeah.
Or let me write that in a different color, sorry. All right, so this is E to the 1/2 ln of 55. I never like, just to like make things nicer for me, I always like, I put this like up here, and then I do
but
E to the
it's
ln.
yeah. Yeah, sure.
Because then it's 55 to the 1/2. So the final answer is equal to the square root of 55. Wow.
You couldn't have guessed this. This is impossible.
Hell no, I would have never guessed this, dude.
This is why I like e to the power, like 1 to the power of infinity, because you never guess what it is.
Yeah, dude, where the fuck? Dude, where did 55 come from, dude? What? That's pretty cool, Narosky.
Yeah.
Okay, so let me like look back like where we started. Where do we start in this land? I see. We started here.
Yeah, and the answer is what we just.
Wow,
reached.
I would have never guessed that. Yeah. I guess the e to the something, but it's very cool that other part here just turned into ln's. That's something new I learned.
Yeah.
That's sick. Okay. This was like the intro one. You said this is the baby one, right? This is the easy one?
Yeah, this is a simple one. This is meant to teach you like how
okay.
to do this. And
All right,
the harder one is.
Okay, we're gonna do the hard. We're gonna do the hard one next. Rampton, do you have any comments about this?
Yeah.
My instinct on that was taking the one of the things I was gonna do was I was gonna add the 1 just to see if some of these work as well. Add the 1 into the original fraction and then factor out
into this one, you mean?
Yeah, so if you add the 1 into the fraction, then you get a 2 as well. And then if you then you're left with 5 to the x plus 11 to the x over 2.
Yeah.
Right? And then if you factor out a 11 to the x from this, one of the two, 5 to the x or 11 to the x.
And you want to factor this out of this?
If you factor out one of if you factor out, then you get the 1 plus 1105 to the x.
Does that work? Wait.
I believe it. Yeah.
No,
Okay.
the whole thing. And then one of the other things that I was thinking also, it's easier if this goes to infinity. So I was gonna flip the variable also. So
I see.
X 1 over y.
Yeah.
Then I would factor out the 11. So then it would be 1 plus 5 over 11 to the
Got you.
x. And then you would factor out the 5 to the x with 1 over to the x, that gives 11 would have been factored out.
Yeah.
And then you would get an 11 to the x to the power of 1 to the x, which just gives you 11. And then the other one, you would get 1 plus 5 over 11 to the x to the power of 1 over x. And then that by definition would be e to the 5 over 11, something like that.
Mm-hmm.
So I feel like maybe that would work as well. I think that would... Because what
get
was the
closer.
answer? It was
Answer is square root of 55.
square root of 55.
I think I know
Then-
what you're trying to say, but it's like you're
Yeah.
trying to scratch. Yeah, you're
I have to
scratch-
do the work, yeah.
Yeah, like this. What you're doing is like very workaround for no reason.
Oh, okay.
No. It's cool to see like what the different like intuitions are for like how to solve this. I understand the add 1, subtract 1 basically because you wanted to get rid of this like right off the bat.
Yeah.
The fun fact is I intentionally gave it this way because initially it was how Rampton said, like the 1 wasn't taken out, and I did it like as an instruction. Like it was gonna be.
Oh,
difficult to
you
explain
created
why.
this question, Narosky? What?
Yeah.
Oh.
I just came with it on the spot. Like.
Oh, that's fucking dope. Okay, but you intentionally did that as like a roadblock to like fuck with going the initial Rampton way, I guess, right?
Yeah,
That's always
it was
fun.
meant to be like it was meant to be instructive because like doing it the other way is like very long.
It's the American brute force way of doing things, for sure. That's how I do things. Okay, cool. I like. Yeah, that's very dope that you were able to like design this question in a way that like forced me to go down a path to like learn something elegant. I was like, oh, that's very cool. I think the key thing I learned was
Actually,
this.
that
What's up, Ramson? Is my internet okay?
I think that is a difference. I think in terms of the European and the American one. I think with the American one, because like the North American one,
Mhm.
mine, the method I learned always was not a brute force in the university. It was more like simplify it as much as you can, and then find the nearest definition, make it look like that.
Uh-huh.
I feel like that was the kind of the general, like simplify it first so you can kind of see what like the thing would look like.
Which we were trying to do to try to make it look like this.
Yeah, I think
right?
for this one, it kind of, you have to recognize that the 5 to the x, 11 to the x minus 2 over 2, that one is like, it's like looks like E.
Yeah.
But then the other way is like you simplify it first, and then you're like, oh, this looks like E, so let me make it look.
I think
Which
a cool thing I've never done
that's like the
is
difference.
using two different variables in limits. Like, I understand that u and x both go to 0, but for me, taking something in terms of u and then raising it to the x power when I already like defined u as a function of x. TikTok's
Oh,
lagging.
interesting. Yeah.
Yeah. It's very cool.
Yeah, and now that you know this method, like I could give you like the actual definition, like the shortcut way of doing it.
Oh yeah, let's see the
Because
shortcut.
when you note, yeah, the moment you notice that it is 1 to the power of infinity, you can immediately write equals e to the power of limit, and just take the flipping, like flip the what you denoted as u, you would flip it, so it's a fraction. It would be 2 over what you had, right?
Sorry,
that make sense?
say that again.
So the shortcut way of doing it is once you notice that it's 1 to the power of infinity,
Okay.
you would just take it as equal to e to the power limit as x goes to 0
Yeah.
of 1 over x, because it's the exponent we have, multiplied by the inverse of the green rectangle that you have
I
on
see.
your screen.
This
So
one.
you just and that's it, like without any using of definitions, any
Oh, I see. Without like going through all
that's
this,
how
you just
like,
recognize that's the pattern.
yeah like without explaining what you did. Like what we did was explaining it, like 1 over u multiplied back by u, right?
Yeah.
Like once you know it, you can just do it, because it's like adding 1, subtracting 1. It doesn't matter if you do it or not.
That's cool. Wow. Okay, where's the harder version? Now that we've learned this.
It's a bit higher. And if
Okay,
you
let
want,
me
I can let you
I see.
try it on yourself.
Yeah, let me try for like a second, you know.
Yeah.
Let's see if I get this. Yes,
Yeah,
I know.
I did give
TikTok.
it for yeah.
Let's see if I would go the same mental route also after the words, because I want to see if it's educational difference.
Yeah, okay. Let's see it. Okay, calculate the limit of this. 2 to the x plus 2 to the 2x plus 2 to the nx 1 over x all over n. Okay. Fascinating. So
This isn't mine. This is I want to make sure this is not mine. This is from a practice book I'm doing.
is this Romanian too?
Yeah.
Okay. Well, I don't see any 1 plus, unfortunately.
Unfortunately, but what
Yeah,
happens if you
unfortunately, I don't
plug
see
in
like a
x
1
equals
plus
0?
something. Oh, I do actually.
Yeah.
Okay, yeah, you're right. Okay. Limit is x approaches 0 of, okay. But man, that divide by n is like messing with me, right? Fuck. Oh, wait. Oh, wait, under, oh, that's just a variable. That's okay. I need to
Yeah.
see.
It's just a positive integer.
Okay. Aren't these all just 1? Or no? These are all just 1, no?
Yeah. And how
So
many
is-
times?
N times. Oh.
So it's just
So it's 1 plus 1 plus blah 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 n times. So isn't it just n?
it is just n.
It's just n. Okay. N over n to the 1 over x. Oh, I see. But now this is our problem, right? Because I can't say what 1 to the 1 over 0 is, right? 1 to the infinity is not like a defined thing, right?
Yeah, it's indeterminate form 1 to the power of infinity. So we do
Okay.
have
I see. This
the
is a
same
problem.
problem as before.
This is the problem.
Yeah.
Same problem.
So
Okay.
you did mention that you do not have your 1 plus something. So why not
Yeah.
just create it?
Let's just create it. Yeah, I like it. All right, cool. But then we'd have to subtract it as well, right?
You'd have to subtract it from the fraction, right? So instead of a clean fraction, you'd have a minus n at the top.
Okay.
Right, that makes sense.
Yes. Okay. I see what you're saying. So, if I wanted to do this 1 plus, I would say 1 plus this, but then minus this, I guess, right? So minus 1. But then n over n minus 1 is n minus n over
Well,
n.
why,
What am I doing?
but why are you doing n over n?
I shouldn't be. Okay, let's do it this way.
Yeah,
Okay.
it's the big fraction.
Okay, so 1 plus 2 to the x plus 2 to the 2x plus blah, 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 2 to the nx, right? Over n, but then minus 1, right? And
Yeah,
then
right.
when I do that, if I want to integrate this into here, this has to be minus n over n, right?
Yeah.
Okay, so now, why doesn't 1 to the x converge? That's a good question, Bears. I think because it's not, because 2 to the 0, it's 2 to the x as x approaches 0. So it's never exactly 1. If that makes sense. You have something that's like slightly greater than 1. And if that's going to the infinity, that like slightly greater than part like keeps compounding. Okay. So this is 1 plus 2 to the x plus 2 to the 2x plus 2 to the nx, or right, dot 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 plus 2 to the x. Ugh. Damn it. Ugh, thank you. My whole body hurts. 2 to the nx, okay, minus n over n. And then this is to the 1 over x, yeah?
Yeah.
Okay. Now, what was the trick we did again? I think I remember the trick is that I set this equal to like
can
u
you-
or
yeah.
something. Let's set this equal
But
to
can
u.
you do it? Yeah, can you do it in one shot without any substitutions, anything? That's the learning part. Like, did you?
That's the
actually
learning
learn
part.
the
Did I actually learn this? Fuck.
Yeah.
Did I actually learn this? Well, yes, I did learn this, Narosky, because I know this is the same thing as the limit as u approaches 0. Or I guess we don't need to do it, right? And I could just say
No,
this is
you can just see it as x goes to 0.
as x goes 0. That's what I want to say.
Yeah.
As x goes 0. And then this is e to the all this stuff, right?
Yeah. And don't forget to multiply by x. 1 over x, sorry.
And is there also
Because
1
that's
over
the
x?
exponent. Yeah, it's over 2x, and it was initially just over 2.
Oh, one sec.
So
Yes,
you
yes, got you.
usually yeah.
Got you. And it's to the 1 over x, so then this becomes this.
Yeah.
Okay.
Yeah.
And now we do L'Hopital's rule.
Do you?
Maybe. Because this is going to be... Oh, no, this is just going to be n minus n. Wait, but that's still 0 over 0. Oh, uh-oh.
It still is 0 over 0.
Yeah, still 0 over 0. So, if it's 0 over 0, that's when I'm tempted to do L'Hopital's, right?
I'm not convinced you would have fun doing L'Hopital with this. I'm not sure if I should let you because I don't see it. but
Well, I guess because these would be ugly, right? That would be it would be n ln of 2, right?
right.
And then this would be like 2 to the x plus 2 to the 2x, right? Blah 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 blah. Which that wouldn't really fix anything, right? But wait, the derivative of this with respect to x would just be n. So then we would be good.
Sure.
So that would cancel. And then as x goes to 0, this would go to n. So would I just get n ln of 2?
N plus 1.
Sorry. No. Sorry. This would become n, and then this would become minus n. Oh, shit. I would still get 0.
Yeah, still get 0, yeah.
I still get 0. Okay, never mind. Okay, nope.
Yep.
Nope.
So L'Hopital's doesn't help you here.
Well,
I didn't think of it before.
I think it does, actually. Sorry. Because the derivative of n is 0. Actually, no. I didn't need the n. Okay, but let's see your way.
Right, so let's just take the limit separately. We don't need to carry the e around with us.
Yeah, we don't need the...
I would factor out 1 over x.
Factor out 1 over x. Okay, so limit.
Yeah.
X approaches 0. 1 over x. And then we have 2 to the x plus 2 to the 2x plus 2 to the nx minus n. This is the key thing. I almost forgot the minus n. All over n. Okay.
Yeah. How many 2 to the power of kx do you have?
I have n of them.
You have n of them, and you have minus n.
Mm-hmm.
Can you switch back to the last problem?
Yeah.
Remember how we have 5 to the x plus 11 to the x minus 2?
Uh-huh. I forgot about this.
Yeah.
This is the key thing.
Yeah.
Which we did prove with L'Hopital's. Okay, so wait.
Which we did, yeah.
So this is important. Okay. So wait, let me think.
Yeah.
So... So this is n times... Oh, man. But I need it like divide... Oh, wait. There's my divide by x, right? Oh,
Yeah.
and then here's my... Here's my 1, right? And then this goes to n.
Yeah.
But it's n... Yeah, okay, so I think I see this. So it's 1 over x. And then we could say n 2 to the x minus n all over n.
So wait, what?
So this represents like a bunch of 2 to the x's, which, I mean, I want to say it's n just times 2 to the x. I know technically it's 2 to the x plus 2 to the 2x plus 2 to the 3x plus 2 to the 4x. But...
So you're I see what you're thinking. You're thinking like
I'm trying to like just
like
say it's...
equivalent.
Yeah, I'm just saying asymptotically it's just a bunch of 2 to the x's, right? Am I allowed to do
but
that?
I don't think you are not allowed to do that.
No. I'd get points off on a math competition, wouldn't I? Okay.
Yeah,
Alright.
you would.
So we don't need points off.
So how many times do you need to add 1 to itself for it to make n?
Oh, okay, wait. How many times do I need to... Oh.
So 1 plus 1 plus 1 plus 1, how many times until you make n?
N times.
Right?
N times.
How many 2 to the kx do you have? You have n 2 to the kx's.
I agree with that.
So why not split your negative x evenly between each exponential
Oh, okay.
term?
So wait.
Right.
So you're saying that like, okay, with this 2 to the x, I'm gonna give it... Well, here, I could give it this minus... I could give it this minus n, because everything's divided by n. Or just...
Yeah,
oh.
give it,
I got you. I think I understand
a
what you're
minus
saying. A -1, but then I need a +1 here,
Yeah.
right? And then I would say +2 to the
why?
2. Well, because if I subtract 1, don't I need to add 1?
But you're bringing it out of your n. You have -n at the end.
Okay.
See?
Oh, this is -n.
So you're gonna yeah.
Oh, okay.
You're gonna split it.
Oh,
You're gonna
got
split
you.
it.
This is like a -1,
Right,
-1,
this-
-1, n times.
Exactly.
Fascinating. Okay, so I'm just distributing this into here. Oh.
This is what we did before with the last problem. We had we had 5 to the x and 11 to the x.
Yes.
And we had -2 at the end. So when you have like multiple exponentials and minus something, you think of splitting it into.
I like that. That's clever.
Yeah.
Oh no, Gladiator. My physics test was so hard today that the teacher gave a couple marks for folding the paper and writing our name. Excuse me, what?
Wow.
I'm gonna write a very lengthy LinkedIn post about like, I don't know. That's just your teachers fuck up a lot when they give tests that are not calibrated to what the students know. And I know people are quick to blame the students and be like, oh, well, the students just didn't study. I'm like, I don't think that's the issue. I think the issue is that what the teacher thinks they taught and what they actually taught are two different things. Like, the teacher is kind of delusional. I get it, you know. It's when you're teaching, you're like, yeah, don't you guys get this? Because, yeah, duh, you've been teaching it for 20 years. It makes fucking perfect sense to you. But these kids have seen it for the first time in their lives, so...
This is why I don't think I'd be a good teacher, because like I would explain stuff. I believe I explain stuff like way too.
You're a great
basically
teacher,
sometimes,
Narosky.
but-
You're a great teacher, Narosky. I appreciate your teaching.
Yeah, but like if I were to give like an actual test, I think I'd give like way too difficult problems, and
For sure.
like that'd be on me, and I wouldn't. Yeah, and eventually I just wouldn't grade them. I'd just say, okay, that was just like.
Oh shit, not good.
Yeah, no, I get
just
you.
for fun. Yeah.
So, yeah. And I kind of learned this as well when I was teaching at UCLA. Even when I would give what I thought was like the most like brain dead, like easy test to do, I would still get people in the class saying that was the hardest thing they'd ever seen. And I'm just like, damn it. Like at some point we do have to have kind of a standard for rigor, right? To be like, no, you need to be able to do this. Like, we can't keep lowering the bar to 0. But I think always erring on the side of making things more easy than more hard will generally lead to a more positive experience in the classroom, and also you won't scare people off as much, so they'll
believe
feel more
the best
capable.
kind of teachers. Yeah, the best kind of teachers have the easiest tests and the hardest classes, if you know what I mean. Like
Yes.
you would go into a test knowing it was going to be easy, but you're going to show up to class knowing you're going to be challenged, like verbally.
Mhm.
Like the teacher is going to give out difficult problems, but work through them with you. Right? You're not going to be scared because, oh, I'm going to get a bad grade because I don't know this on the test.
Right.
Right? You're going to think like, oh, I'm going to go to class and I might not know something, but I'm going to learn something.
But I'm gonna learn,
right?
yeah.
Because he's going to teach me. Yeah.
And this is the carrot or the stick, though. Unfortunately, the test becomes the stick, because otherwise, especially like if you're teaching to pre-meds, they don't actually want to. For instance, when I teach physics to pre-meds, they don't actually want to learn physics. It's just one of their requirements. So they don't ever want to show up to class. And again, I shouldn't say everyone, but in general, they don't show up to class because they want to learn physics. They show up to class because they want to get a 4.0 so that they can go to med school.
Yeah.
And so, yeah, that's the problem. So maybe we should just get rid of like required classes outside your interest. Just be like, you know,
True.
if you want to go to med school, why are you taking physics? I mean, I get it. Like, some things from physics
Yeah, like,
transcend over, but you don't really need to take it.
yeah. Like, when are you going to use physics? Unless you're like
Yeah,
in
you're not.
anesthesiology or something.
Yeah, even then, you're not. I mean, I will say the one unique thing that physics does is it teaches you how to solve problems in a very unique way.
Yeah.
I think that is very different from how these pre-meds learn how to solve problems in, for instance, biology and chemistry, which is just memorize. So,
Sure, yeah.
anyways. Narosky gets
Yeah,
it.
many
Narosky
things.
does get it, dude. Narosky gets a lot of it. Okay, let's finish this one up. Because Jacob actually,
Yeah.
we have someone
Yeah, so
did
just-
submit a
yeah.
question. We will do their question. Jacob, don't worry. I'm getting to you. All right, so this Narowski is a bunch of these fun things, right? Which is this.
But yeah, it is this. Yeah.
It is
so
this.
I was actually I was wrong to bring out the 1 over x. It was supposed to be 1 over n. But that
Yeah, let's
doesn't
bring out
happen.
the 1 over n.
Yeah, and bring back in the 1 over x.
Okay, let's
That
do
was
that.
my fault.
No, that's nothing's your fault, dude. That's great. Okay, so then this is this plus this plus this, but each one of those is an ln of 2, right?
Yeah.
Okay, so this is an ln of 2, and then also this one will be an ln of 2,
Careful.
right?
It's ln of 2 squared, is it not?
Oh fuck. Oh, you're right. Cuz it's 2 to the 2x. Oh. Narowski. Wow. Okay. So then this
Yeah.
will be ln of 2 to the n. Okay. So then I have 1 over n, the sum from whatever, like a equals 1 to n of ln of 2 to the a, right?
Yeah. Which is just gonna be a times ln of 2.
Good. Okay. So 1 over n.
Yeah.
A equals 1 to n. A ln of 2. Beautiful. So then, so then it's just n ln of 2. Oh shit. Is the answer just ln of 2?
Oh wait, what are we doing?
Uh-oh.
Disqualified.
Sorry, it's e to the ln of 2. So then the answer is just 2.
No.
Oh,
Because
I
why is it?
Oh, I fucked up.
What is
sorry.
what is the sum of 1 plus 1? Wait, 1 plus 2 plus 3 plus n.
Oh, you're right. Yeah, I'm dumb.
Yeah, that's a mistake.
Yeah. Nope. Okay. Oh man, my sick brain is not working. Okay, I get it. So, this is the arithmetic mean. No,
Gauss's sum. I don't know how you call it.
I think do we call it like
Yeah.
right? Like so, 1 plus 2 plus 3 plus blah 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 is equal to the same thing as whatever this is, right? N plus 1 over n times n. Is that
N
how that
plus
works?
1 over 2.
N plus 1 over
So
2
it's
times n.
times n. Yeah.
Yes. Yes.
Yeah. This is Gauss's sum.
Gauss's sum. Okay. And so this, I can pull out the ln of 2, right? So this is ln of 2 over
Yeah.
n. And then we have m plus 1 over 2 times n. But then one of the n's will cancel. So then I have 1/2 ln of 2 times n plus 1. But, it was the limit as n approaches 0, right? Is that what we said?
No, it was of x. It was the limit as x.
Oh,
so
just
you-
for
you
any
basically
value
just
n.
finished. Yeah, for any value, like positive integer n.
But this is e to the.
E to the power of this, yeah. So let's simplify.
Yeah, let's simplify. So this isn't going to do anything crazy. So that's going to be e to the n plus 1. And then this will be the square root of 2. Right? Do that right?
No.
Because the
So
1/2
it's gonna be-
goes up. So it's ln of 2 to the 1/2. Then e to the ln of 2 to the 1/2 is just 2 to the 1/2, which is square root of 2.
Yeah, but isn't it like why? Because can't you bring the n plus 1? Can't you bring the n plus 1 to the power of ln of 2? Bring it in. Because it's multiplied by n plus 1.
Oh.
Because like basically, yeah. Like
Oh,
you're
I see what you're
multiplying
saying.
By n plus 1.
When I see, okay, right, because like if I see e to the a times b, right? That's the same thing as e to the a, e to the. No, it's not. No, I'm okay. No, yeah. I give up. Dude, I'm making basic. God damn it. All right, fine. E to the ln of 2 to the 1/2, and then this is all to the n plus 1, right? That's what that is,
Well,
right? Like this.
It's wait. So it's ln of 2 to the 1/2 times n plus 1, because like you're multiplying by n plus 1 over 2. Like the ln of 2 is multiplied by n plus 1 over 2. It's not multiplied by 1 over 2. Like it's multiplied by n plus 1 over 2. Do you see it?
Okay. Wait. So the ln of 2 is multiplied by n plus 1 over 2. Got you.
Yeah. So yeah.
Oh, I see what you're saying. You're saying I can't selectively pull this thing in. Oh wait, no, I can. Right?
Yeah. You can, but why are you doing that?
I don't know.
Because it's just going to be an extra step.
Is it just it's just this, right? Plus 1 over 2.
Yeah.
Okay.
Yeah.
Okay. So then it's
Yeah.
just 2 to the n plus 1 plus 2. Okay.
Yeah.
We got it, right? Yeah.
That's the answer. Yeah, that's the answer.
Oh my god. Fine. I apologize. My brain is like absolutely retarded right now because I'm sick.
No, it's okay. It's okay.
It's kind of fun to see the struggle. Okay.
I'm glad we didn't do functions.
I think this is really fun though. This is really cool.
Yeah.
Wow. Super dope. This is a cool trick. Gauss' sum was a cool trick. And then me literally like stumbling over myself trying to remember logarithm rules. And just basic exponent rules.
No, it's okay.
God damn it. I'm really sad. Okay, cool. That was dope. Here, I'm gonna actually save these in our Discord because they were kind of fun. And then
Yeah, sure.
let's see what Jacob's got. Yeah. Let's see. Jacob. Clever tricks. I learned. Thank you, Naroski. I learned so many clever tricks today because of you.
No problem.
I hope you guys watching also learned some stuff. Probably did, right? I definitely learned some shit.
That was pretty cool. Yeah.
Yeah. Ramson said it was cool. Going a little backwards, 1 to the 0 is not an indeterminate form, I don't think. It's 1. Yeah, no. Well, 1 to the infinity
course.
is indeterminate. Indeterminate dojo, I think is what we were saying.
Yeah, 1 to the infinity is when anything to the 0 isn't except 0 to the 0.
Exactly, yeah. This was math. I'm gonna say very cool things. You got it, Jojo. Yeah, all good, dude. Alright, let's see. What else we got? Let's go to the... My computer's lagging for some reason. I see my frame rate dropping. What's going on? Okay, let's see. Jacob, what do you got for us? Hell yeah. Some physics. This I can do. And it's Canadian. Love it. Canadian physics. Dojo says, I've just spent 15 minutes trying to find an f of x and g of x such that 1 to the 0 is indeterminate. What class is that for, Dojo? Alright, let's see. This might be grade 11 physics. It didn't work out. Uh-oh. Yeah, this is I think like physics 1, honestly. It's not terrible. All right.
All right. If you don't mind me, I might call it here.
Yeah, you're good.
But
Yeah.
it was nice. Yeah, we should definitely do some physics questions also at some point where we like do word problem. I feel
Yes.
like that's something I feel like a lot of people have trouble with. It would be nice.
I agree.
'Cause I feel like you're pretty good at it.
I do like the word problems. Yeah.
Yeah.
I'm a fan of these. Oh, send me the stuff for the podcast episode. And I'll make an announcement.
Yeah. I think. Yeah. I'll put it into a file and then I'll send it to you probably like.
Perf. Okay.
Well,
Good to see you,
have a
Ramton.
good night. I will.
You too, man.
All right. I guess good.
Good
evening?
day. Good
For you?
evening.
Yeah,
Good
good
evening,
day.
dude. It's a good morning to Narowski.
Alright.
Good late night to Narowski.
Yeah. All right. Bye.
Peace. Okay. Here we go. A bike rider accelerates to a constantly. Constant acceleration is nice. If acceleration isn't constant, like, you gotta deal with some weird stuff. Dude, the special relativity stuff. Yeah, the long ladder into the short garage, dude, that still messes me up, dude. Special relativity gives me nightmares. Still. But okay, for this one, whenever I see like kinematics questions like this, I like to write out what the different parts of the word problem give me. So, we accelerate to a velocity of. So that tells me that like v final is equal to 7.5. Dude, your retakeable physics test. I don't understand what's the obsession these days with retakes. But you are right. Like almost every student I work with now always talks about like I need to prepare for my retake. I need to prepare for my retake. And then like students get mad if there isn't a retake. And at least from the instructor's side, dude, it sucks having to give out retakes. You have to create a whole new exam. It takes a lot of time to create an exam. And then you got to grade the exam. So, I don't know. I understand like teachers being like no retakes. Because it's a lot of time. You shouldn't have fucked up the first time. But I think teachers should offer corrections. I think that's the middle ground of things. You should let students get points back if they can acknowledge what they did wrong and they can explain why they did it wrong. And that's what I do in my classes. I don't offer retakes. And also, nobody in college offers a retake. Once you get to college, there are no retakes. If you fuck up an exam, you fuck up an exam. But they at least offer, at least what I do in my case is I offer like half credit back if you do corrections and explain why you got it wrong. Yeah. I don't know. This kind of goes down to, I see all these rabbit hole theories about how video games have changed for this generation versus the last generation. So my generation, just due to like computational limits, we didn't have checkpoints. We didn't have like save games. You had to just like kind of beat it in like one go. And if you didn't beat it and you lost, you were punished.
You done messed up, AA Ron!
Like you had to go all the way back to the beginning, or you had to go back to like the last level. And then they talk about like as video games progressed with later generations, they started letting you save the game like wherever. So people just started like going save. Like, oh, I can always go back. Yeah, right. So it's like here I am to fight the boss for like the 300th time because I have a save point right before it. But I think that gets rid. So it gets rid of the there's no risk. You become incredibly risk adverse at this point, which is not how the world works. You don't get save games all the time in the world. You have to like prepare. You have to go in. You have to, it's scary, but you got to just like perform and you got to do well. And if you don't, learn for next time, but you don't get to redo it. There are no redos. My rant about video games, and it's all connected. It's all connected.
Yeah. Dark Souls versus Elden Ring.
There you go.
Is
that the good comparison? Does Dark Souls have a ton of save points, but Elden Ring doesn't, or what's the comparison?
No, the other way around.
Oh, okay.
Same genre, different time.
I think of Elder Scrolls, but I see Elder Ring is a new game, right? Is that a new game, Elder Ring, by Amazon, right?
Yeah.
Amazon Studios. Yeah. And then you're saying Dark Scrolls is the earlier one where you didn't have like save games.
Yeah.
Yeah. Back in the day, it was like Baldur's Gate or like, Elder Scrolls. We really want to go back. Morrowind, like that. Those are the old games that we used to play. Anyways, okay. So here to do this question, this is v final 7.5. The time is 4.5. The distance 19. That's delta x, and then they're asking for v0. Whenever I see these types of questions, I just think about like which kinematics variables do I have and which one am I missing? Yeah, exactly. Psychode. Yeah, you had to beat Mario in a single run. This is actually something I was talking about with Ramton. Do you remember the one version of Mario that a cosmic ray came and like fucked up one of the bits or something in the game, so that it accessed like or it was like unbeatable or something, or you got like just some secret level or something, all just because of the randomness of the universe caused it to like flip a bit on the data on the cartridge or something. That's something really cool. I forget the exact story, but yeah. No milk and honey shit. Yes. Oh, it's a classic thing. The clockwork glitch. Yeah. Is the glitch because of like cosmic background radiation happening? I feel like that's what it is. I feel like there's like a lone like gamma ray or something, and it just like smacks like a bit on the chip, and then like that unlocks something else. I want to look this up now. Sorry. Oh, that's the hypothesis. Oh, okay. Okay, cool. All right, yeah, got it. Dr. Gold, do you have Gen Physics 1 vids? Yeah, I mean, I have some videos on my YouTube, actually. If you want to go check them out. I'll show you guys real quick. Because actually, this thing we're doing right here, I've done like a tutorial video on YouTube, and they're short. So here, if we go to our, if I type in like kinematics, where is it? Here we go. 1D projectile motion in physics made easy.
Here's how to solve them.
So if you ever want to watch this video, this kind of like shows what I'm basically going to teach you guys right here, which is you look at the equations, you see which one's missing, which one's given. So yeah, go check it out. Actually, I just posted a video today on inverse trig functions. Let's see how it's doing. Nice, 666 views.
You done messed up, AA Ron!
Look at that, 666. Oh my god. Oh no, Alistair. Pentagram City. Okay, so yeah, so we're looking for V naught, right? This is what I think about when I see the kinematics equations. I need something that has VF, V naught, T, and delta X in it. And the only one that has that, wow, interesting actually, is this
one.
one.
You don't have any acceleration. Yeah, you
Yeah.
don't have acceleration.
It's this one, right? Yeah.
Yeah.
Average velocity times time equal distance. Yep, and that's what this is. This is a weird kinematics equation, this one. It's not really usually taught. Usually you get like these ones. You don't really get taught this one, but yeah, you're right. Yeah, so distance 19 is equal to average velocity, which is V naught plus VF divided by 2. So V naught plus 7.5 all over 2 times the time. That's pretty cool. Wow, okay, cool. And then, yeah, you need a calculator technically for this one. So I don't know, because I can't do 38 divided by 4.5 in my head. Or maybe I should be able to.
Well, it's going to be 30 times 2 divided by 9. No? So it's, yeah,
it's 9, isn't this 19? 19 times 2 is 38, and then we're going to divide by 4.5. 8.4
yeah,
repeating.
If you divide, yeah, if you divide by 4.5, you actually multiply by 2 and divide by 9. So you
Oh,
don't
true.
divide by a decimal.
Gotcha,
Yeah.
gotcha.
It's the same thing if you want to divide by 5, you never divide by 5, you divide by 10 multiplied by 2, right?
Oh, I like that. Okay, so instead of doing divide by 5, you're saying multiply by 2 and divide by 10. Oh, that's cute. That's clever.
So just, yeah.
That's a cool trick. Oh, man. Okay. Okay. V naught's 0.944 repeating.
Nice.
Gladiator said, I found this cool simulation link for physics. Okay. Oh, Matt Craig. That's cool. I wonder what he builds these in. And he's got a YouTube tutorial with him. Oh, let's go check this guy out. What's he got? He's only got 9 subscribers? No. We need to help this man. Physics and science with math. I'm just kind of curious. Let's see what he does.
This is a tutorial for this simulation.
Oh, very cool. I wonder how he built these, actually. I guess nowadays you can vibe code everything.
What?
Yeah, isn't it kind of fun?
What?
Wait, he built it
Imagine
in...
you just take a physics exam.
Yeah, because you can literally just like add forces and stuff.
Yeah. Yeah. Wow.
Whereas, I don't know, I need a little getting used to this, but yeah, you can add masses and stuff, and oh, you can start like doing this. Dude, look at all this. You can turn on the UK mode. Oh no, oh that's the friction. Oh, very cool. Okay, cool. Yeah, simulations are cool. Matt.Craig.space wants to look for and connect to any device on your local network. I don't think about that. Oh, it's built on HTML5 canvas. That's cool. That's cool. What's the guy? What is that? You know that it reminds me of the FET simulations. I'll show you guys what I'm talking about. This stuff, which is kind of old school, but they have some fun ones. Here's like, you know, like do this stuff. You can move magnets around and shit, and like, yeah. But cool, Gladiator. I didn't know about that. How'd you find out about this guy? Where is... He's got sheet music too? What? Wait, what? Why is this man selling also the sheet music to Top Gun Maverick? Dude, what? Yeah, I need to learn about this person, sorry. Who the fuck is this guy? I'm a musician, programmer, and science teacher in Toronto. I teach high school physics, yeah.
Yeah, teacher, plumber, astronaut, musician, programmer, science.
He's a pianist and arranger as well. Okay. I fuck with it. This guy's kind of cool. Okay, I feel like I should contact him. Yeah. Wow, he also just like plays the piano, dude. Oh, fuck yeah. Okay, cool. Maybe he's been on some TV shows, it looks like, too. Okay. Very cool.
Wow, this guy has to be like an undercover. He's a
Fed
billionaire or something.
Or you think he's a Fed?
He has to be something. Alien or Fed or billionaire.
Dude, he's also a high school teacher, dude. What?
Yeah.
Yeah. Very cool. Okay. Well, thank you for showing me this person. I at least like followed him on YouTube. Very unique character. I can empathize with it, you know. I like music and programming and all sorts of weird stuff, and also teaching. Okay. Dojo says average velocity times time equals distance because distance is the integral velocity. Thus, the area under the graph of a straight line between two velocities is the area of a trapezoid. Oh, that's actually really cool. I like that, Dojo. That's a cool way to think about it. That's the calculus way to think about it, right? Yeah. You're saying if you had, I don't know, well, I guess this is time, right? And then this is velocity, right? And then whatever, this is like V naught, and then this is like V final. And then, yeah, let's say this is like T naught and T final. You are right, though, yeah. From that to that, the area underneath that would be a trapezoid. That's very cool to see the calculus explanation for it, yeah. Right, because integral of v dt is equal to delta x. And this is, yep, 1/2 v naught plus vf, right? Base 1, base 2, and then times the height times delta t. Very cool, which is the same formula. Very dope.
That's dope.
That's cool. That's cool, Dojo. Okay. Let's see. I think that's how my teacher, last year's teacher, introduced it, but without the calculus. Yeah, I mean, the calculus is fun because then you have like more of an appreciation for it, I feel like. But yeah, that's cool. That's a really cool way to show it. I didn't think about that. Okay. This is V naught is 0, V final is equal to 600, delta X is equal to 0.9, and now they're asking for A. So
this is just.
This is easy, right? Yeah, we know this one.
Yeah.
That's this equation. Right?
Yep.
V final, V initial, A is missing. We have delta X. So what is that? 600 squared is equal to 0 squared plus 2 times A times 0.9. I don't think this is anything really nice. My A's look like 9s. I understand that.
So what is this? 36? No, it's 360,000.
It's huge, right? Yeah. Right?
Yeah,
600 squared
360,000 divided by. Yeah. Wow.
divided by 0.9 and then divided by 2.
Yeah.
It's a big number, no?
It's just 3.6 million divided by 18, which is just 2 times 10 to the 5th.
I think it's 2 times 10,
Right.
10 to the 6.
No, because if it would be to the 6th, it would be.
Oh, you are right. It is 2 times 10 to the
3
5th. Yeah. It's 200,000.
Yeah. Yeah.
Wow. Crazy. That's a big number there. I don't know. That's a huge acceleration.
What gun is shooting this rate? Like, what?
Yeah, that's it. Well,
Yeah.
I guess that makes sense. I mean, that's a pretty... Wait. Yeah, no, that's pretty... Is that standard? No, I think most guns shoot at like... Yeah, no, they do. Most guns do shoot around like 600 meters per second.
Dude,
I think that...
wow.
Yeah, muzzle velocity. See, let's say muzzle velocity for, I don't know, 308 M1 Garand. Yeah, around 2,600, 2,800 feet per second. Yeah. So yeah, that's around, yeah?
Yeah, well,
That's huge. That's crazy. Okay, Randy Johnson. Who remembers Randy Johnson? Wow, I know this is an old book. This is an old book if they're talking about Randy Johnson. Randy Johnson was a baseball pitcher when I was in like middle school. Like high school. Also, he was a
it's crazy
pitcher.
that Michael Jordan. Yeah, Michael Jordan is next.
Yes, yeah, okay, there we go. This is immediately dating ourselves, right? Yeah, this is a very we've now narrowed the date of this to like probably the early thousands. Maybe 90s.
Yeah.
Also, Randy Johnson's a pitcher. He doesn't hit the baseball. A hang time. So this question is interesting because technically he doesn't hit the ball from the ground, right? He hits it from like I mean, if you want to get really technical, the initial height and the starting height are not 0.
Yeah, but I don't think it's.
I think we just don't fucking care, right? Yeah. Okay. So here, you have delta X is equal to 0. V naught is equal to question mark. V final is equal to question mark. The acceleration of something in the air is always negative 9.8.
Yeah.
And we're trying to figure out T. Oh, we have T. So
Yeah, and we want velocity.
yeah. Yeah, so actually I don't really care about final velocity, right? Well, final velocity will be the same as initial velocity, but opposite direction. So that would be this one. So we get 0 is equal to V naught times 6.25 minus 4.9 T squared. I just combined the 1/2 and the 9.8. Okay.
Yep.
Oh, but we know what T is. This one, I don't see any way to do this in your head. This is not, you can't do this in your head. Narowski's like, try me.
Well, you can divide. You can divide by
6.25. You could.
6.2.
You are right. You could pull out one of the 6.25s.
And then you just have velocity, right? So it's just.
Yeah. So velocity is equal to 4.9 times 6.25. Right?
Yeah. And whatever that is.
Which, you know, if you wanted to approximate the acceleration of gravity as 10, then that just becomes 5 times 6.25.
Yeah.
And then that's not bad, right? Because then that's just 31.25.
Yeah. Yeah. In all my physics exams, I've always written, like at the beginning, even in my contests, I always just say I approximate g to be 10 meters per second squared.
Wow. That's funny.
Yeah. And I
like it.
I just refuse to pull my calculator out.
Yeah, like I'm not doing it. Okay. Pi equals 3. Yeah, Psycode says, do you also approximate pi to be equal to 3?
Pi equals 3, yeah. In physics, it doesn't matter.
Doesn't
math
matter.
is different. Math is a different story.
Okay, this is delta x is equal to 1.29. V naught is the question mark. Vf, however, we know is equal to 0 when he gets to the top of his height, top of the apex of the jump. A is equal to, we're going to say negative 10 here.
Yeah.
So then this is just we already did this equation. It's this one again. It's this one. So 0 equals V naught squared plus 2 times negative 10 times 1.29. So, yeah. What was that 25.8 square root of 25.8?
Yep.
Okay. Which is about 5, right? I like this. Let's just do it fast. Yeah. All right. So like 5.1. Much slower than the bullet.
Yeah. And the difference, the difference between doing it with 10 and 9.8 is so small when you're doing square roots that it doesn't matter. Like, I think we are off by like 0.5 or something.
I see, it's close enough.
Yeah.
Nice. Okay, good job, guys. We did
This
physics.
is what I mean because it doesn't matter. Like, because in physics you have a lot of square roots and logarithms. But
Yeah.
you don't have a lot of big numbers.
Well done! Well done!
So the difference is like.
Because I guess logarithms is only when it really starts to make a difference. Is that what we're kind of saying? The difference between 9.8 and 10.
It only makes a difference when. No, because logarithms are small.
That's true.
I'm saying it's like, yeah. The big differences appear when you have like linear or like exponentials.
Mm-hmm. Yeah, exponentials for sure. Nice. Good question, Jacob.
Yeah.
Alright, let's see what else we got on the list.
I might log off.
You're good.
'Cause
I appreciate
it's
Narowski.
getting kinda
Thank.
late.
I know it is late, and we're just doing boring stuff, anyways. Although some of this is actually kind of interesting,
Yeah.
but I appreciate. Thank you, Narowski, for teaching me today. It was really fun. I'm looking forward to doing more of that with
No problem.
your own stream on Fridays. That's really cool.
That's like a little sneak peek.
Little sneak peek, little preview, guys. Little preview. I'm gonna use that. I'm gonna use that as like the sneak peek preview to advertise for the next Friday. Okay, get some rest, Narowski. Thank you, dude. Appreciate you.
Right. See you guys.
Peace. All right. Let's see. I'm trying to like grab this. Why can't I grab this? In physics, it doesn't matter. That's a ban. Yeah, right. Paste, please. Okay, here we go. Evaluate. Ooh, these are fun. What's going on here? Okay, let's do 69. Okay. At least they're all the same base, which is nice, right? So the key property I'm going to use here, Gladiator, is that log of A plus log of B is equal to log of A times B. So this and this is going to be log base 2 of 3 times 5. And then that's going to be minus this. This is actually really interesting. You gotta do this in product, but you gotta be clever. Some people would like combine this, and then subtract them. That's wrong. Yeah, you can't do that. You have to do like sum, and then you have to divide, and then you have to sum. I think you go left to right, Psychode, yeah? So, I think if we really wanted to do it right, it's like this. It's 3 plus is times 5. And then all of that is being divided by 15 over 8. So you can say times 1 over. Sorry. Okay. 1 plus. Bless you. Thank you. 1 times 1 over 15 over 8. And then times 2 to the 4th. I love the curiosity that this channel creates. Someone designed a round that travels at more than 1 mile per second out of an AR-15. Oh, wow. That's impressive. Wait, 1 mile per second? Wait, what? That's fast. That's really fast. What type? That's a crazy round. Wait, what? I guess it's not. It's definitely supersonic, right? Yeah, because what speed of sound is 300 meters per second. Oh wow. Okay. Well, I guess any round is supersonic. Okay. So that's going to become 15. I think he is, yeah. LFD Research Wildcat. Oh, okay. So it's 15, and then it's like divided by 15, and then like times 8, because the 8 comes on top, and then times 16 to the 4th. So this cancels. And then we just get 8 times 16, which is just 128. Or log base 2 of 128. Oh, okay. This is actually cool then. Because, yeah, well, there's Dojo. There's what are called, I think, blackout rounds. 300 blackout rounds. Yeah, and they're subsonic. Right. So those go around 1,000 feet per second, which I guess is less than the speed of sound, right? Speed of sound is 343 meters per second. Right, exactly, yeah. Yeah. The crack. So, and the other cool thing here, right, is that 128, anytime you see log base something of something, try to write this in terms of this to a power. 128 is the same thing as 2 to the 7th. And so then this gets you the log base 2 of 2 to the 7th, which is equal to 7 log base 2 of 2, but log base 2 of 2 is 1. So the answer is just 7. You could have maybe also seen that from here. See how this is like 2 to the 3rd times 2 to the 4th? That also gets you 2 to the 7th. Nice. Okay, let's look at B. So right off the rip, whenever you see this, something raised, if the base and the base here are the same, this is just 10. This is like, for instance, like e to the ln of 3 is just equal to 3. What's up with my TikTok chat? Just came in randomly. Log base 2 of 2 to the 4 equals 4. Correct. You're correct, Cool Shapes. That's fine. Yep. Yeah, this would have been 4. But it was 8 times 16, right? So you would have to have done log base 2 of 8. This would have also been this would have been log base 2 of 8 plus log base 2 of 16, and 16, right, is 2 to the 4th, and then this is 2 to the 3rd. So that would have gotten you the 3 plus 4, which equals 7 as well. Logs are cool. There's just like so many different ways to do it. This one, right off the rip, is just 10. Because anytime you have base to the log base of a number, it's just the number. Okay, and then, interesting, 1 over log base 3 to the 10. So that's minus log base 3 to the 10, all to the negative 1. I don't know about that one yet. Let's just leave it. Let's actually just leave it for now. I'm actually a little confused with this. Sorry, what? Because this is the whole thing to the negative 1, not just the 10. Right? If it was just the 10, yeah, I could just pull it out front. We might need to get, like, common bases maybe for this. Let's just leave it how it is. And then plus log base 10 thirds to the 1/3. This is the same thing as pulling this down, and then this is 2 dividing logs, so you can subtract them. I also assume this is log base 3, right? I think we have to assume that. Okay, so that's 1/3 log base. What's up, Walking Stick? Thanks for the raid, Walking Stick. Appreciate you. What were we talking about today? You always have some fun, like, debates on... I saw you were, like, kind of tearing apart an anti-vaxxer, like, one of your streams. That's kind of cool. Oh, I totally fucked this up, man. My first 10 is wrong? Wait. This is wrong? Is this not just 10? This is like e to the ln of like 10. Right? And isn't that just 10? I believe it is. Also, I erased it all because I was being dumb. Okay, sorry. So this is 10 minus... Oh, okay, I'm good. All good. No, please question me. I'm a little under the weather, so my brain is not working at optimal peak performance right now. Oh, okay, all good. Yeah, no, I can see that too, yeah. So this is cool. Because this, when you have the log of 2 things dividing by each other, I assume this is log base 3, you do the log of the top one minus the log of the bottom one. Okay, so now we have this. Oh, dude, why is it not looking correct? Oh, that is weird. What the hell? Okay, it's this plus 1/3 log base 3 of 10 minus 1/3. Remember, the 1/3 has to hit both things. Log base 3 of 3. Okay, well, the log base 3 of 3 is just 1. So this goes away. This is just 1. So then I have... Oh, if there isn't a base, isn't it assumed to be 10? I guess so. In Mathland, technically, if there isn't a base, it's assumed to be ln. If it was just 10, though, I think that would mess some shit up for me. computer science, we assume it's 2. Okay. I guess it works both ways, right? Okay. So here. Let's assume it's log base 10. That's fine. We can do that. That's cool. I think your teacher might have made a mistake with this question, but... Okay, well, in that case, this one goes to 1. And then this is still here. Which, this is already just looking ugly, dude. All right, so 10 plus a third, so what? 31 thirds minus 1 over log base 3 of 10 minus 1/3 log base 10 of 3. Yeah, spoiler, it's the same thing but base E. Okay, so there's another trick you learn. So if you have log base A of B, this is the same thing as log of B divided by log of A, where this is whatever base you want it to be. So you can assume it's base 10. So let's do that here, okay? So this is 31 thirds minus 1 over log base 10 of 10 over log base 10 of 3. Let's assume that log is just log base 10. And then we're going to say minus 1/3 log base 10 of 3. Which is just log of 3. Let's just say it's log of 3. Yeah, okay. Because now this will flip, right? So now I have 31 over 3 minus log 3 over log 10. But log 10 is equal to 1. And then minus 1/3 log base 10 of 3. Oh, very cool. So this is 31 minus 4 log 3 all over 3. Right? Because I have a log 3 minus 1/3 log 3, which is 4/3 log 3 minus 4/3 log 3. I think that's it.
Oh, yeah.
We can check it real quick with chat. Curious. See what chat wants to think. Bam! Yeah, there we go. Okay, let's just check it. We'll say simplify. Again, if you're just joining us from YouTube, best way to submit your question for us to go over it is go to this website, actualofficehours.com. You can drop in your username, drop in a screenshot. We'll do it live on the stream. Click here. This is the queue of questions. So, not too big of a queue today. It's a holiday, so I understand a lot of people are just taking off. And then make sure you join our Discord. That's where we post all the solutions for everything we do. And then if you check out the streaming schedule here, you can see all the other awesome times that all of our friends are streaming. So we'll have another stream tomorrow. And then Zach and Penn. Rage Against the Machine Learning? What is this? Oh, this is cool. Penn has a Rage Against the Machine Learning series. Oh, I'll have to check that out. Okay. So I think we got that one. Let's see if... Yep, ChatGPT agreed. Good, yep. 31 minus 4 log 3 over 3. Yeah. Okay, I'm gonna skip the graphing because like graphing just like sucks. Get out! But I can do this one. I like these, like compressing into logs. These are fun. Ooh, okay. So whenever I compress logs, I always want to like strip them down so that there's like nothing in front. Okay, so I don't like this 3 being here. So I'm gonna like put it back up as an exponent. So this is, and also I don't like square root things. I like those as exponents. So I'm gonna say this is the same thing as log of x to the 1/2 to the 3rd. That's what this is, right? This turns into x to the 1/2. The 3 comes up as a power. And then we have minus log x to the 5th to the 1/2. Same, right? Yeah. That's how I like to do things. Okay. So, yeah, there's another cool thing here, which is anytime you have like exponent to an exponent, technically you multiply the exponents together. So this would be the same thing as log of x to the 3/2 minus log of x to the 5/2. And then if you're subtracting logs, you can divide them in a single log. So now this is log of x to the 3/2 over x to the 5/2, which is equal to, 3 minus 5 is -2. Oh, just log of 1 over x squared. Is that right? Which is the same thing. No, I fucked up.
Surprise, motherfucker.
Did I? No, x is 1 over x. There you go. Sorry. Yes, 3/2 minus 5/2 is -2/2, which is -1. Correct. Yes. This is also the same thing, though, as negative log of x. Because this is the 1 over x is the same thing as x to the -1, and then the -1 just comes out. Okay. Oh, this is fun. Okay. 2 logs subtracting. Notice there's nothing in front, so they're stripped, they're clean. So we can do log of x squared minus 14x minus 32 all over 3x plus 6. Now, I do believe that this will factor into something. It has to, right? So, like, what multiplies to -32 but adds up to -14? It's probably 2 and 16, yeah? Taco Cat, 40 stream streak. What's up, dude? Right, so this little part here is, I think, going to be x minus 16, x plus 2. Looks about right. And then this, I can also pull a 3 out of, right? So now we have the log. Restrictions for what? Oh, restrictions. Yeah, the restriction is x has to be greater than or equal to 0 here. Or x has to be greater than 0. You're right. Yeah, so you look at your final thing here, right? Whatever is in here has to be greater than 0. But also looking at the original conditions here, right? This is kind of also the other one. Well, okay. It's interesting. Square roots, you can't have negative numbers. But you can't have 0. But then logarithms, you can't even have 0. So it just has to be greater than 0. Also, we have to... I mean, and that goes without saying, right? Whenever you divide by things, you have to be careful that thing couldn't have equal. We're gonna see that's gonna play a part here. Watch. So this is gonna turn into this, and then we're gonna have that all divided by, and then I'm gonna pull out a 3, and then this is gonna be x plus 2. Now, yeah, here's the tricky domain restriction. Is that when I end up eliminating this, okay, technically x cannot equal -2. Because getting rid of this gets rid of the solution when x is equal to 0. But that's already enforced here, right? Because look, 3x plus 6 has to also be greater than or equal to 0. Sorry, it also has to be greater than 0, sorry. So it can't even equal -2. So I think this is just log of 1/3 x minus 16. Or, yeah, that's probably the best way to write it. So the restrictions on the variable... Huh. Well, from this one, x has to be greater than -2. And then what about from this? X has to be greater than 16? I agree with that. Yeah, right? Yeah, because your zeros are at 16 and -2. But the second x is less than 16, then this becomes negative. And you can't have you can't do logs of negatives.
Nice.
Yeah, so from this one, x has to be greater than 16. So yeah, that is the restriction. And actually, I think you see that here, right? You see that in the final result. Because all of this has to be greater than 0. And the only way this is greater than 0 is if x is greater than 16. Yeah, exactly, Psycode. Cool. Nice. Good question, Gladiator. That's pretty cool.
Well done! Well done!
Nice. Good job, Gladiator. Okay. Next one. Thanks for the follow, by the way. CED Killer 001. It's a cool username. What is CED? What do you not like about CED? Lil Bro says. What is all this? Oh no. Okay. Thin film interference. Is this you, Psycode? You dropped this on me, dude. You dropped some optics on me, dog. I'm pretty sure you did this. Okay. 2 thick pieces of glass. It's cool. It's incremental. Okay, cool. Yeah. We'll do it. This might be the last question, just because the queue's short, but also like I need to go take more Dayquil or something. Okay. The thickness of the thin layer of water is as illustrated for this problem. You can use class notes. Good. Okay. What is the optical path length between points A and D in the figure? Unlike in class, the refractive for the surrounding medium is not air. Express in terms of NG, NWT, the angle of incidence, and the angle of refraction. What is the path length? Oh, okay. Did I smell optics? You did. Alright, here, let me... I'm gonna need to draw a couple things on this, so I'm gonna take this out. OPL? What does OPL mean? I assume path length is what they're talking about, like this, right? This is the path length they want for this? Optical path length, yeah, okay. Well, I think I would want to use Snell's law, right? To figure out what this distance is. Wait, and there's... Did you Snell the optics? There's also something, I think if you're going into a higher index of refraction, the wave flips, right? This is NG and NW. Okay. I want to see if I can get this. Because I feel like this distance, right, is 2 times this distance. And then once I have that, I know what this angle is, so then I can figure out this distance. That's the geometry I see. One sec, I gotta see. Okay. Ugh, this fucking flu is kicking the shit out of me. Damn it. I need to get better. I have to get on a plane in 3 days. Okay. This is theta I. I'm going to call this like theta W. Let's call it theta water. Yeah, I'm just going to ask it kindly to like, flu, can you please just leave me? Thank you. Okay. So, NG sine theta I is equal to NW sine theta W, right? So that'll get me what this angle is, which is cool, because if I want to know this distance, I also need the sine. This is really cool, actually, how this works. Okay. Because let's see. This distance right here for this triangle. Let's say for here, right? This is equal to this distance, t, sine theta w, right? Sine theta is opposite of hypotenuse, okay? And then I believe that this distance is twice this, right? So this is 2t sine theta w. And then eventually I think we're trying to get this distance, which we could get from this angle, right? So this angle has to equal this angle, right? Because this angle equals this angle. Oh, I think. Yeah. Right. This angle equals this angle. So this is 90 degrees minus theta I. And then from there, if I'm trying to get AD, I would say that the cosine of 90 minus theta I is equal to AD over AC, right? And then in this case, AC is 2t sine theta, right? So this is 2t sine theta W. But then sine theta W is the same thing as NG over NW sine theta I. Right? So from this, NG over NW sine theta I is equal to sine theta W. So AC is equal to 2t NG over NW sine theta I. Just plug your nose with tissue, trust it. Yeah, just stop breathing. Okay, cool. So then that has to go into here. And then here's the cool thing. Cosine of 90 minus theta I is the same thing as sine of theta I. The same thing as sine theta I. So I spy with my little eye that sine theta I equals AD over this. Which, funny enough, when we multiply through, you're going to get 2t NG over NW sine squared theta I is equal to AD. Nice. Is that correct? Psycode says good. I'm proud of myself. Okay. What is the optical path length between points A to B to C? Right, got it. Oh, no. So, Starprod, the reason we don't have many questions today's a holiday. I technically should have canceled today's stream. I forgot today is Martin Luther King Day, so nobody has school today. Yeah. In the U.S., today's a holiday. We love our holidays. It's like any excuse not to do things. America, yes. Soon to be the United States of Greenland. What's going on? Okay. A to B to B to C. You're in the wrong place if you can't handle this now. No, you're good. I want to finish this one and then I'm going to go rest because I think this is cool. Okay, A to B to B to C Well, these are the same, no? Right? I think A to B. So A to B to B to C is just 2AB, right? So this is for question A. No, I like the Psycho. This is cool. Because I don't think I've done thin film interference myself, like, in a while. So, A to B to C is equal to 2AB. Which is equal to... let's think about that. So, sine theta W... no, I want cosine. Right? Cosine theta W is equal to the adjacent, which is equal to T over AB. Okay. So, AB is equal to T over cosine theta W. Am I allowed to do that in terms of theta W? Oh, but we want to do it in terms of theta I. Got it. Okay. So 2AB is 2T cosine over cosine theta W. But then from here... Ooh, but I want the cosine. Fuck. That's going to be annoying. Right? Because I have that sine theta W is equal to this. Snell's law, right? Yeah. Cosine theta. Oh, we're allowed to use theta transmitted? Oh, that is theta T. Oh, very cool. Okay, cool. I didn't. Okay, great. Whatever. I'll just say it's okay. From your answers, A and B in Snell's law, what is the difference in the optical path length which leads to interference? Ooh. So I need the difference in path length. Okay, so that's like going from here versus just going here. That difference in path length needs to be half a wavelength, right? When you do C, okay. Now, wait, why do I have to multiply by the index of fractions? Sorry. Yeah, what was interesting is actually... this one didn't have any index of refraction in it, right? Optical path length is index of refraction times distance. I calculated the distances. Oh. Oh, I think I see what you're saying. I didn't know that. Yes, it's okay. You're right. So optical path length is the effective distance it travels. Right, okay. Yes, because technically it slows down in the medium. Okay. Oh, very cool. I didn't know that. Okay. Very cool. So, difference. Which would need to be equal to lambda over 2. And let's do the big one minus the small one, right? So that's going to be NW. So 2 NWT over cosine theta W minus this, which is 2 NGT sine squared theta I over NW. Oh, but then we need to multiply this by NG as well, right? Are you saying that right? For optical path, I need to multiply this by ng as well. So this is ng squared. Which is interesting, right? So in order for these to have common denominators... Okay. Show that the condition for constructive interference in that is that. Okay. So I think this is what it is, right? Oh wait, what am I solving for? Sorry. Okay. And then I think they want to... Oh, well, okay, sorry. So the answer for the first one is just this. It's just it's just lambda over 2, right? And then part D is when there's constructive interference, which means the difference needs to be lambda, right? And then I think we want to show it looks like the other thing. Let me think how we do that. So, it's not that much more advanced. It's just called thin film interference. What's up, X-Man? Okay, I want things just in terms of theta I. So I think I want to rewrite this. But it's cosine. You get them on Sunday, Star Prod. Yeah, I process all the coins on like Sundays. Multiples of lambda, sure. So m lambda. How am I going to combine these though? You got a different answer in C? Okay. Did you get the same answer for B that I did? And A? My A is incorrect. Okay, fine. 2. Okay, we'll see what I did wrong here. So, yeah, okay. How I did this, right, is I figured out what this distance was. Which we said was, Oh, I know why this is wrong.
You're not that
Sorry,
guy.
because this is not T sine theta W. Sorry, this is... T tangent theta W. Right? Because tangent of theta W is opposite over adjacent. The adjacent is T. Yeah, that's where I fucked up. So this is 2T tangent of theta W. Thank you. And then we showed that cosine of 90 minus I is sine of I. Okay, so then this is... Okay, I need to make sure we got this right. Yeah, that was a mistake. Yeah, I got you. Okay, the problem is I can't like follow my own work of what I did here. So AC is equal to 2t tangent theta w. I think we're gonna leave that because this doesn't give me sine over cosine, so this actually doesn't really help me yet. Okay, so oh, I see where this might help though. Let me see. Okay, cosine is the adjacent of hypotenuse. Hypotenuse is that. Adjacent is AD. Yeah. The last thing I got is correct. This right here. Okay, cool. All right, so AD 2t sine theta I tangent theta w times ng. Okay, gotcha. So that's gonna be 2ngt sine theta I tangent theta w. Okay, cool. Okay. All right, and then now to like combine this with Snell's law. So Snell's law, come help me here, Snell's law. Because I need everything in terms of theta I, right? So the cool thing here is tangent of theta w is the same thing as sine theta w over cosine theta w. So I can actually combine these, right? So now I'm going to have 2t, and then that's going to be 2t over cosine theta w. And that's going to be nw minus ng sine theta I sine theta w. Which, are we getting closer? Oh, they have they have something with like 1/2 in it. Equals m lambda. So I believe for this, interesting, they want everything just in terms of theta, cosine theta w. Okay, cool. And that's what I do have. I do have this. So maybe this goes away somehow? I'm getting there, right? Yeah, okay. I know from Snell's law that this is true, right? Oh, I think I see it. I think I see it. So wait, ng sine theta I is the same thing as nw sine theta w? Yes, exactly. Thank you, Hamiltonian. Beautiful. It's actually really cool. So this is Snell's. So this goes in here. And so then I have nw minus nw sine squared theta w. Cool, so now I can pull nw out. So now I have m lambda is equal to 2t over cosine theta w. There's another nw that comes out. And then this is 1 minus sine squared theta w, which is cosine squared. So then m lambda is equal to 2t nw cosine theta w. Okay. That's not exactly what they want. Let's see what we want. Or maybe it is. This is what they want. That is correct. Okay. This is what they want the answer. Sorry, but I think for constructive interference, right? I need it to be yeah, a whole wavelength. It has to be a whole wavelength. Where are they getting this 1/2? I see this. 2nt nw cosine theta w, which is theta transmit. Why are they saying m plus 1/2 though? Wouldn't the path length difference need to be... Oh, the phase shift. Yup. Oh, that's so clever. Yes, exactly, Hamiltonian. Yeah. So, what's the rule? So, first of all, yeah, glass is higher than water, right? Water's like 1.3. Right. Exactly. So, this is no phase shift. Thank you, Sipe. Bless me, dude. Yeah, bless my health, please. Yeah, okay. So, there's no phase shift. However, yes, going from here to here, when you go from lower index of refraction to higher index of refraction, you do have a pi/2 shift. Okay, cool. So, yes. So, in fact, I don't want it to be m lambda. I want it to be m plus 1/2 lambda. Wait, m. Yes, m plus 1/2 lambda. Or 2n plus 1/2 or something, right? Okay. Yeah. Very cool. Nice, cool, we did it. Yes. Thank you, Psycode. That was a good, just in general, like, just exercise. Super cool. Yeah, no, I appreciate that one. It wasn't too tough, but it wasn't too easy. And that type of optics I like. I'm cool with that type of optics, you know? Those are my optics. Yeah, I'm okay. Just do the application. Yeah, I'm tired. I think I'm gonna call after this. Yeah, there's a party. Whenever I see like just plug in numbers, I'm like,
Surprise, motherfucker.
I don't want to plug in numbers. I don't live in real land. It's trivial. Okay, cool. All right, let's close the stream. All right, thank you everyone for coming to Actual Education Office Hours today. I apologize. I'm a little under the weather, but we did it. We did some problems. I had fun. Hope you guys are enjoying this vacation. It is MLK Day in the U.S., so yes, I will for sure. I will get better. Yeah, I think this is the worst. I think it has to be better tomorrow. There's no way it can get worse. But yeah, make sure go check out our streaming schedule here because we're gonna be on again tomorrow, same time. Actually, sorry, an hour later. Sorry, we're starting at 6 p.m. Pacific tomorrow, 7 p.m. Mountain, 8 p.m. Central, 9 p.m. Eastern. Also, Zach has a cool stream beforehand doing math through tasks. This sounds fun. So make sure go check out our other awesome friends. And yeah, if you're watching us on Twitch, we're gonna go raid somebody. And I'm gonna go take a nap. Who are we gonna go raid? Dun, 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 dun. 5K follower party and a farewell to studio stream. Having to move out. Oh yeah, let's say hi to her. I love Casey. She's great. She's moving out of her studio. She's awesome. I met her actually at TwitchCon. She's another science. Well, she's art, technically, but she's a part of the whole science community because she does a lot of cool stuff for like conservation and like animals and shit. So yeah, go check out Casey. We love her. We will see you guys tomorrow. Peace.